Hello class, welcome to lesson 5, and we're going to be spending this activity doing more reasoning with pattern blocks. And oops, I went one slide off. Okay, so on pattern blocks, okay, these should look familiar from the last lesson, okay, but we need to pay close attention to what is happening here. So the directions in this case say if the trapezoid represents one whole. Okay, now this is different. Okay, so don't think this is the same as yesterday or whenever we did the last activity, right? Because last time it was the hexagon that was one whole, but not now. Now it's the trapezoid, it's this. This now represents one whole, all right? So it's different. Okay, but the idea is we want to still compare the following shapes to what one whole is. In this case, it's just this trapezoid. And we want to be able to explain our reasoning. So what I've done is I've put in a link to the applet again, so we can play around and make sense of the shapes. So here they want us to find what one triangle represents as compared to the one whole that is a trapezoid, right? Not the hexagon of yesterday. So we're going to select a trapezoid, and then we're going to fit triangles into it and see how many we have. So here we go. All right, so we'll scroll down and back to the blocks here. And so now one whole is the trapezoid. So I'm going to move this here, and we want to see how many triangles fit into a trapezoid. So let's go ahead and move this out, see if we can fit one in. There's one. All right, let's get another one. There's two. All right, and then I'm going to have to rotate this one around. There we go. There are 3 of them, right? They're not 100% perfect, but you can see they would fit together nicely in a puzzle. There are 3 of them. So we know then that the triangle represents 1/3 of the trapezoid. Okay, 1/3. For the rhombus, that's the blue figure. All right, so let's go ahead and get another trapezoid. And let's plug some rhombuses in. How many rhombuses can fit into the trapezoid here? There's 1. All right. And so, that looks like it could be kind of difficult, right? It looks like if we try to put 2 in, we're going to have extra. So it's not going to be, that's not going to work for us, right? So we need to think about something else. So if we think about the rhombus, how many triangles are going to fit into a rhombus? Here's an idea we can check for. If I go in here, there's 1, and once I rotate it around, there is 2. Okay, so how much was a triangle again? A triangle was 1/3, and so 2 of them fill in a rhombus. So 2 of the 1/3 triangles fill it in. So 2 1/3, that's 2/3. Okay, so a little different, right? And then for the hexagon, so we're talking about one hexagon compared to the trapezoid. So if we grab a hexagon, okay, we know that's, in this case, now going to be more than one whole, right? Because if the trapezoid is here, okay, if we try to move this over, you can see that the trapezoid only takes up half of the hexagon. We need another one, right? And so rotating it around so it fits in there. Okay, there you see it. So the hexagon is actually 2 whole trapezoids. So it's going to be 2. All right, so that is important. Okay, so the next part here wants us to use pattern blocks to represent each multiplication equation. Okay, use the trapezoid to represent one whole. All right, so for part A, we have 3 times 1/3 equals 1. Well, which piece was 1/3? It was the triangle. So what this is telling us is that we need to put 3 triangles together to make one whole. So let's take a look at that here. If we put 3 triangles together, we already actually have it right here, right? We actually have 3 triangles right here, and so that's going to be one whole, okay? And so you could also have, of course, the trapezoid. That's one hole. 3 triangles equals 1 hole. So this is what's going to work for 2A. All right, and then for 2B, they say that 3 times 2/3 equals 2. Well, which shape did we say was 2/3? We said a rhombus was 2/3, right? So 3 of those will equal 2. So if we get 3 rhombuses, there's 2 and 3. We got to put these together. We rotate it. All right, there's 2. There's 3. 3 pieces. Each one is worth 2/3 each. Okay, and you can see that right there. And so that's going to be equal to 2 whole trapezoids. So you could also show 2 whole trapezoids like this. You could take your figure and rotate it around. Okay, so that's kind of hard to see. Let's go around this way. Okay, there you go. That's 2 holes. Okay, so there's a couple different ways to represent this. Okay, there's that. So there's a couple of ideas on how to represent the 2 equations. All right, then for number 3, Diego and Jada were asked how many rhombuses are in a trapezoid. So Diego says 1 1/3. Says if I put 1 rhombus on a trapezoid, the leftover shape is a triangle, which is 1/3 of the trapezoid. Jada says, I think it's 1 1/2. Since we want to find out how many rhombuses, we should compare the leftover triangle to a rhombus. A triangle is half of a rhombus. Okay, so the idea here is we're talking about rhombuses and trapezoids. Okay, how many rhombuses are in a trapezoid? Let's take a look. Let's grab a trapezoid. Okay, and here is a trapezoid. How many rhombuses are going to go into this here? Well, let's see what we can do here. So we move one over. Okay, that's kind of not in there. Let's see. We can rotate it a little bit. This one. Okay, there's 1. Okay, we have 1. Let's bring another one up here. Rotate it. Looks like it might be too big. Okay, looks like it could be too big, right? So we're going to have extra. So if you look right there, look at that. Okay, there's extra that's there. Okay, so there is a triangle that's sticking out, right? There is a triangle that's left over. So if you look at what Diego says here, he's right. There's a leftover shape that's a triangle. Okay, but Diego said that the triangle is 1/3 of the trapezoid. Okay, but we aren't comparing it to the trapezoid. We're comparing it to the rhombus. A triangle, as you can see here, is half of a rhombus. You can see the example right here, right? A triangle makes up half of a rhombus. So what's left over is half of a rhombus. So because of that, Jada is correct. So we can put a little check mark by Jada. She's correct. Okay, and I just explained why, right? It's half of a rhombus that's left over. The triangle that's left over represents half of the rhombus. Okay, so select all equations that can be used to answer the question, how many rhombuses are in a trapezoid? Well, okay, so if we look at it here, what we know is that we are taking the trapezoid, that is, here's a trapezoid, I'll move one out here, taking this trapezoid here, and if we want to know how many rhombuses we go in to the trapezoid, well, we know that the rhombus is 2/3 of a trapezoid, right? So that means we're going to be taking the rhombus, the trapezoid I mean, and we're going to be dividing it into pieces that are that size. Okay, so that means we're going to be taking the 1 whole, I'm just going to write this out here, we're taking the 1 whole trapezoid and we're going to be dividing it into the pieces that are 2/3 each. Okay, so that's what that means. That's one way to think about it. Put a little equals and a little question mark there. So that's one way to think about it. You can also think about it like this. So if you want to know how many rhombuses go into a trapezoid, remember the other way, the multiplication version of that is we're going to be taking the size of the rhombus, that's 2/3, and we can multiply that by however many there are. So 2/3 times some unknown. So we can also take this and say 2/3 times some unknown amount. And that's going to give us the 1 whole. Okay, so these are the ways that we can think about this situation here. So what we can do is we can go through each of the possible answer choices and see which ones fit would be the same as this here. So 1 divided by 2/3 equals something, or 2/3 times something equals 1. So here we have 2/3 divided by something equals 1. Well, no, we just said it's 2/3 times something. So because of that, we can't use that one. That's not going to work, because we can't just have everything be the same and just change the operation and not change anything else. That's not how it works. Okay, and then for B, it's question marks times 2/3 equals 1. Let's look at our options here. So 2/3 times an unknown, okay, or an unknown times 2/3. Well, those are the same thing. Okay, so that is going to work. All right, that'll work. And then look for C. 1 divided by 2/3 equals something. 1 divided by 2/3 equals something. Yeah, that works. C will work. Okay. 1 times 2/3 equals something. Well, here we go again with this. You can't just leave everything the same and just change the operation and call that the same thing. No, that's not going to work. We're going to put an X by that. Let's make sure this is an X as well so we don't get confused. Okay, and then here, question mark divided by 2/3 equals 1. Well, we just said question mark times 2/3 equals 1. That is correct. So then we can't leave everything else the same and just change the operation and call that the same thing. It's not. Okay, so the 2 correct choices are these 2 here. All right.